Hi there and welcome back to yet another session here. Today we are going to look at relations and functions. These chapters appear both in your 11th and 12th standard syllabus, and it's mostly the 12th standard syllabus of relations and functions which is important from the JEE examination point of view. In fact, the 11th standard subject is important for you to get a very good understanding, which forms the basis of a lot of chapters including calculus. So you cannot actually neglect the 11th standard chapter even though that does not come directly in the JEE examination. So let's divide this chapter into two topics, relations and functions, and look at them separately. Relations. Now we begin in your 11th standard by defining a relation, looking at the number of terms in a relation. We also look at domain and range of a relation sometimes, but that's not as important as domain and range of a function is. And also we look at inverse of a relation, again not as interesting and important as the inverse of a function is. Before moving on to the most important topic from your JEE main examination point of view from relations, which is the types of relations. So each year in the past few JEE main examination, one question has inevitably come from relations, and this question has been from the types of relations. Now let me quickly brush you through what these types of relations are. We have a reflexive relation wherein a relation A is a part of the relation, which means every element is related to itself. Then we have the symmetric relation wherein if P is related to Q, then Q is also related to P. Then we have the transitive relation wherein if X is related to Y and Y is related to Z, then X is also related to Z. Now if all these three types of relation is satisfied by a relation, if a relation is reflexive, symmetric and transitive, then such a relation is called an equivalence relation. So all these are very interesting topics from relations, and normally in the advanced examination questions don't appear from relations, but in the main examination inevitably one question comes from types of relations. The next section of this chapter, which is functions, is the most interesting bit of this chapter. Because when it comes to functions, a lot of questions come from functions in the advanced examination, and functions also sort of forms the basis of calculus. In order to understand calculus, you have to at some level understand functions and their graphs. So what do we see in functions? We begin by looking at the definition of a function and then move on to three very, very interesting concepts, which are the domain, codomain and range of a function. Of these three concepts, the most relevant concepts are domain and range calculations are really, really important because you get questions in your board examination, in your JEE main, in your JEE advanced. In all these different examinations, you have questions of different levels of intensity appearing from domain and range. Then based on mapping, we classify functions in some ways. And this is also an important concept wherein we classify functions as a 1-1 function, onto function, both 1-1 and onto, which is then defined as a bijective function. These are also very interesting concepts, and questions do appear from these concepts in the advanced examination. Then we move on to the concept of inverse of a function. Now that's also a very interesting concept, and understanding invertible functions is quite mandatory moving forward in your 12th standard syllabus, because without understanding this, a lot of concepts, a lot of chapters on the whole will be things that you will not understand, especially when you go to inverse trigonometric functions. Unless you have a sound understanding of inverse functions, it will become very difficult for you to grasp the concepts that are covered in inverse trigonometric functions. So inverse functions is again another important concept from which a lot of questions come in all the different exams that you will be taking. Then we do have other types of functions. We have the odd and even function. So when I'm talking about other types of functions, I am talking about the absolute value function, the greatest integer function, and their derivatives such as the signum function, etc. So it's important to understand these functions and their graphs and how these functions are translated in the coordinate plane, rotated in the coordinate plane. All these are important. And in functions, one thing that I would say is very, very important is to understand the graph of functions. You should understand how to play with graphs. Playing with graphs is an important concept, and it is covered in the chapter on functions. So you should know how to play with graphs, because without knowing how to play with graphs, you will struggle in the whole of coordinate geometry and in a lot of sections of calculus. So functions is a really important chapter, and we close functions in NCERT by looking at binary operations. Now again, binary operations is more of a main level concept than an advanced level concept, so most of the questions from binary operations appear in main exam. So sometimes one question appears from binary operations in the main examination. In fact, in the past 4 or 5 years, every question which has come from relations and functions in the advanced examination has been inevitably from one of the concepts of functions, mainly from concepts such as domain and range, or graph of a function, and then to look at the nature of functions such as the 1, 1, onto, and the bijective function. So these are the most important concepts from the JEE advanced examination point of view. When you talk about binary operations, the interesting bits in binary operations are properties of binary operators, such as the commutative property, the associative property, and then you have the identity element and the inverse element. All these are interesting concepts that you can probably brush through once before going into the main examination. But for the advanced examination, focus more on functions. And because functions is what is really interesting from the advanced examination point of view, in this lecture, we will be looking at some interesting questions from functions and try and solve them in the most effective manner, which will help you solve these questions super quick in the advanced examination. So let's have some fun solving these questions. So in this question, we've been given the value of f1 of x to be equal to x divided by x minus 1. So this is the expression for f1 of x. Further, an expression for fn of x has been given in a recursive fashion. They've told that fn of x is f1 of fn minus 1 of x, right? So this is a composite function here. The objective is to find out the integral value of x satisfying the equation f101 of x is actually equal to 3x. Looks like a slightly convoluted problem because we've been given f101 of x, and there doesn't seem to be a way in which we can very easily find out f101x. So let's start it in a very systematic way and see what f1 of x is, f2 of x is, f3 of x is, and try to build a pattern. In case a pattern emerges, then we're lucky and we can solve this problem easily. In case a pattern doesn't emerge, then we'll think of other ways in which this problem can be solved. So what is f1 of x? Well, f1 of x has been told to be equal to x divided by x minus 1. So what will f2 of x be? According to this formula here which is given, fn of x is f1 of fn minus 1 of x, which means f2 of x is f1 of f1 of x, right? So f1 of f1 of x. So now I know what is f1 of x, right? f1 of x is nothing but x divided by x minus 1. So the argument for the f1 which is outside is now not x but x by x minus 1. So wherever there is an x, you're going to replace it by x minus 1. So in this expression for f1 of x, you're going to replace x divided by x minus 1, and then find out what is f1 of f1 of x. So f1 of x divided by x minus 1 will nothing but x by x minus 1 divided by x minus 1 minus 1. Now I'm going to simplify this. If you take a common denominator in the denominator, you will find out that the x minus 1s will cancel out, and there is an x in the numerator, and in the denominator you will have x minus x plus 1, which will be just 1. So f1 of f1 of x is x. This seems to be quite interesting. So f2 of x is x. What is f3 of x? f3 of x is f1 of f2 of x, and f2 of x is just x. So f3 of x in fact is f1 of x, which is x divided by x minus 1. Now this seems to be giving us an interesting pattern, right? f1 of x and f3 of x are exactly the same. f2 of x is x. In fact, f4 of x will also be x, isn't it? f4 of x will be f1 of f3 of x. f3 of x was nothing but f1 of x itself, and we know f1 of f1 of x was x. So f4 of x will also be x. f5 of x now will be f1 of f4 of x, which is f1 of x, which is nothing but x by x minus 1. So in fact, I have actually created a pattern. So fm of x is going to be nothing but x if m is even and x divided by x minus 1 if m is odd. So if 101 of x is an odd number, 101 is an odd number, so if 101 of x will be nothing but x divided by x minus 1. So now I have a very simple linear equation to solve, in fact a quadratic equation to solve, which I'm going to solve like a linear equation. Because I have x divided by x minus 1 equal to 3x, I can cancel out the x's if x were to be equal to 0. So if x is 0, that's one of the solutions. I cancel out the x's and then I have a linear equation to solve. I'll have 1 is equal to 3x minus 3, which upon solving gives me the value of x to be equal to 4 by 3. So I've got two solutions, x is equal to 0, x is equal to 4 by 3. Makes sense because a quadratic has been solved. So what is the answer to this question? What have they asked in the question? They've asked us the integral value of x satisfying that equation f 101 of x equal to 3x. Which out of these two values is integral? Of course, 3x is equal to 0 is integral, x is equal to 4 by 3 is not an integer. So x is equal to 0 being the integer is the correct answer to this question. Not a very tricky question. In fact, such questions are pretty routine in relations and functions. You just have to find out a few terms and find out a pattern. Such questions are also very common in matrices and determinants. If you would have solved some matrix questions, such deriving a pattern of this kind is a trick that helps you solve such convoluted questions wherein you have to find out the 101st matrix, or in this case, F101. So find out the pattern and then solve this question in a pretty easy way. A very interesting question. Here's yet another very interesting question. Now in this question, they've given us the definitions of two functions, f of x and g of x. This is f of x, this is g of x. Now these two functions have been defined in particular domains. So the domains of f of x and g of x can be seen from the function definition. The objective of this question is to find the number of roots that the equation f of g of x equal to 0 has. Now it's not a very straightforward question, but it is not a very difficult question also. The only thing that you must understand in this question is you must be very careful when you play with the domain of f of g of x. So let's do it in a very systematic way. Let's define what is f of g of x. So f of g of x would be nothing but wherever there is x in the definition of f of x, you're going to replace it with g of x. So if you see here, f of x is x plus 4 when x is less than 1 or less than or equal to 1. So f of g of x would be equal to g of x plus 4 when g of x is less than or equal to 1, right? And also when x is between 1 and 2, the value of f of x is 2x plus 1, which means when g of x is between 1 and 2, the value of f of g of x would be 2g of x plus 1. This is the first thing that we do. We define what is f of g of x in a very systematic way. Now let's look at the two domains of f of g of x. One is g of x is less than or equal to 1 and the other one is g of x is between 1 and 2. But the domain is always mentioned in terms of x and not g of x. So now we need to work a little more there. For that, let's look at g of x. G of x is nothing but x square when x is between negative 1 and 2 and x plus 2 when x is between 2 and 3. So now what happens when x is between negative 1 and 1? Let's just consider that interval for the case. When x is between negative 1 and 1, my g of x, which is equal to x square, where is g of x going to lie? G of x is going to lie between 0 and 1, isn't it? Because when you put negative 1 or positive 1, you're going to get g of x equal to 1. And when you put 0, you get the value of g of x to be equal to 0. So between negative 1 and positive 1, g of x is going to lie between 0 and 1. So now look at the function definition of f of g of x. The function changes its definition when g of x becomes more than 1, right? Which is why I have considered this particular interval wherein g of x lies between 0 and 1. Now what happens if x is greater than 1 but less than 2? If x is greater than 1 and less than 2, the definition of g of x is still the same, which is x square, right? So what is the value of g of x between x of 1 and 2? If x is between 1 and 2, g of x is going to be between 1 and 4. Correct? If x is between 1 and 2, g of x is going to be between 1 and 4. Now, there is another definition of g of x which is given when x is between 2 and 3. The value of g of x is x plus 2. So, if x is 2, g of x is going to be 4. But let's have a look at f of g of x again. Now, f of g of x is not defined if g of x is greater than 2. The domain of f of g of x cannot be there when g of x is greater than 2. So we are not going to consider any case where g of x is greater than 2. So now my new definition of f of g of x in terms of its domain x is going to be this. So f of g of x is going to be g of x plus 4, which is x square plus 4 when x lies between -1 and 1, or in other words, g of x is less than or equal to 1. It's going to lie between 0 and 1. What happens when g of x is between 1 and 2? When g of x is between 1 and 2, the value of f of g of x is going to be 2x square plus 1, right? Because g of x is still going to be x square itself. Now, what is the value of x here? The value of x here is going to be between 1 and root 2, because g of x cannot go beyond 2. So when is g of x 2? When x is equal to root 2. So now when x is between 1 and root 2, the value of f of g of x is going to be 2x square plus 1. This is the tricky bit in this question to get the domain correct. But in fact, the way this question has been designed, you don't have to do all these things. In case the objective of the question was to find out the domain of f of g of x, this is how you should have done it. But there is no other way to solve this question apart from this, because you need the definition of f of g of x, and for that you need the domain. But you don't have to be so careful about the domain, because the domain is not the question in concern. So f of g of x is x square plus 4 or 2x square plus 1. What is the objective? To find out the roots of f of g of x equal to 0. Now let's look at f of g of x. F of g of x is x square plus 4 or 2x square plus 1. X square plus 4, both positive numbers are getting added. 2x square plus 1, again, two positive numbers are getting added. When two positive numbers are getting added, is there ever a possibility that the sum is going to be 0? No. So f of g of x in fact can never be 0 when x lies between -1 and root 2. Well, -1 to root 2 is actually the domain of f of g of x. So f of g of x is always going to be greater than or equal to 0 in its domain, which means f of g of x can never be 0 in the domain. So this equation f of g of x is equal to 0 has no solutions at all. So the correct answer to this question is actually 0, because f of g of x equal to 0 has 0 solutions. Now let's look at yet another concept, and this concept is periodicity. So here's the question from periodicity. So in this question, they've given us two composite functions, f of g of x, and they've defined it as mod sine x. G of f of x has been defined as sine square of root x. The objective is to find out the periodicity of f of x and g of x. I'm a little confused, because how do I extract f of x and g of x from these two composite functions? They don't look similar to me in any way, except for the fact that both of them have signs somewhere. Apart from this, they don't look similar to me. So let's try and see if we can make these two functions look similar to each other. We can then draw a pattern out of it and then probably find out what is f of x and g of x. Let's see if there's some connection. What do I see in f of g of x? I see a modulus function. What do I see in g of f of x? I see that the argument of sine square is a root. So I see a square in sine and I see an under root in its argument. There's a modulus, there's a square, there is an under root. Is there some connection between these three functions, the square root function, the square function, and the modulus function? In fact, there is. Because the under root of the square of something is nothing but the modulus of something, right? So if you have under root of a square, this is nothing but modulus of A. So now I'm going to rewrite my f of g of x, which is modulus of sine x, as under root of sine square x. Now f of g of x is under root of sine square x. G of f of x is sine square under root x. Now there is a sine square, there is the under root. Now things are making more sense. There is much more coherence between f of g of x and g of f of x now, right? So as soon as you see this, the question becomes very easy. Because look at f of g of x. F of g of x is under root of sine square x. So if f was nothing but the under root function and g was the sine square function, does it work for g of f of x? G of f of x would be sine square of under root x. Of course, g of f of x is sine square of under root x. So f of x is under root x and g of x is sine square x. Now you see we've actually extracted f of x and g of x from these two composite functions. It was all about identifying the connect between f of g of x and g of f of x. As soon as you do that, this question is as good as solved. Now you need to find out the periodicity, and you know that the under root function is not periodic, whereas the sine square function is periodic. So the answer to this question is that f of x is not periodic, but g of x is periodic. Not a very difficult question if you get the first trick correct. Next, let's look at yet another type of question. This type of question is the multiple correct answer kind of question. Remember, such questions appear only in the advanced examination, and these days multiple correct answer kind of questions have partial marks for each of the correct answer. So even if you don't have the time to attempt each of the options, you can attempt some of the options and get correct partial marks for each correct answer. Now this is one such question where you can look at one or two options, mark them and get partial correct marks, because each of the four options are four separate questions on their own. The objective of this question is to find out which of the functions given in the four options are bijective. Now, what are bijective functions? Bijective functions are both injective and surjective, or in other words, they are both 1, 1 and onto. So functions which are both 1, 1 and onto, or injective and surjective, are called as bijective functions. Why are bijective functions interesting? Bijective functions are interesting because they are invertible in nature. So the objective is to find out which of the four functions given are bijective. So let's go and check each of the four options. The first option that is given is the function e to the power signum of x. Now, what is the signum function? The signum function is nothing but modulus of x divided by x when x is not equal to 0, and it's equal to 0 when x equal to 0. Now, this means that the signum function equal to -1 when x is negative, it's equal to 1 when x is positive, and equal to 0 when x equal to 0. So what is e power signum x? E power signum x is e to the power -1, or 1 by e when x is negative, 1 when x is equal to 0, and e when x is greater than 0, or x is a positive number. Well, this function is not a 1, 1 function clearly, because for all negative values of x, the function maps to the same image, which is 1 upon e. For any negative value of x, it always maps to the same value 1 upon e. What about when x is positive? When x is positive, the case is exactly the same. Each of the positive numbers will map to the same value, which is e. Clearly, this function is not a 1, 1 function, and because its codomain is given as 0 to all the positive numbers, 0 to infinity, this function is not an onto function also. So this function is neither 1, 1 nor onto. So clearly this function is not a bijective function. So option A is not a correct answer to this question. Let's move on and look at option B. Now in option B, we've been given a function which is defined between 3 to 4. The domain is 3 to 4 and the codomain is 4 to 6. The definition of the function is this: it's a sum of 4 moduli. So now let's try and evaluate these 4 moduli here. Because the function is defined in the domain 3 to 4, these moduli here will open in this way. X minus 1 and x minus 2 and x minus 3, in fact, all the 3 of them are going to be positive when you put a value of x in between 3 and 4. But x minus 4 is going to be negative, so it's going to be minus of x minus 4, which is going to be 4 minus x. So the definition of function in 3 to 4 is going to be this. So one of the x's will cancel with the negative x. 4 minus 3 minus 2 minus 1, that is going to give me minus 2, and I have 2 x's. So f of x in the domain 3 to 4 is going to be 2x minus 2. Now 2x minus 2, that's a linear function and it's going to be a 1-1 function. Now we have to check if it is going to be an onto function. So my x is between 3 and 4. What happens when I put x is equal to 3? When I put x is equal to 3, I get 2x minus 2, which is equal to 6 minus 2 of 4. When I put x is equal to 4, I am going to get the value 8 minus 2, which is going to be equal to 6. So the function is going to lie between 4 and 6, isn't it? The range of this function is going to be between 4 and 6, which is exactly what the codomain of this function is. Since the range and the codomain are exactly the same, this means that the function is an onto function. So this function is both 1-1 and onto, so it is a bijective function. So option B, which says that this function is a bijective function, is a correct answer. Option B is one of the correct answers to this question. Moving on, let's try and see what has been given in option C. In option C, they've given a function which has been mapped from real numbers to real numbers. And the definition of the function is this: it has a greatest integer function, also has a greatest integer function inside the argument of cos. So what happens to this function in the domain is what we have to see first. The domain is quite a big one because it's the set of all real numbers. So let's break the domain into a lot of subdomains and see what happens there, because there is a greatest integer function. So let's take the easiest subdomain, which is going to be x lying between 0 and 1. X is greater than or equal to 0, but x is less than 1. What happens in this subdomain? The greatest integer of x is always going to be equal to 0. So now my function definition in this subdomain is going to be 0 plus cos of pi times 0. Correct? Because greatest integer of x is going to be 0. Now what is cos 0? Cos 0 is 1, 0 is 0. So f of x is going to be equal to 1 in this entire subdomain, which clearly means that this function is not a 1-1 function, because whenever you put a value of x, anything between 0 and 1, it's all going to be mapped to the same number 1. So this function is not 1-1. Clearly this function is not bijective. So we conclude option C as not a correct answer to this multiple correct answer kind of question. Let's move on and look at option D. What is given in option D? In option D, we have yet another function which is mapped from the set of real numbers to the set of real numbers, but its definition is the minimum of two linear functions x plus 2 and negative 2x plus 4. So this question I'm going to solve it graphically. So let's plot x plus 2 and negative 2x plus 4. So this is going to be x plus 2. This is going to be negative 2x plus 4. So look at the function. These two functions, x plus 2 and negative 2x plus 4, is going to intersect at one point, and it's very easy to find out the point of intersection. You have to solve these linear equations, equate them, and you solve a linear equation, you get the point of intersection to be equal to 2 by 3, 8 by 3. So at 2 by 3, 8 by 3, the functions intersect. So at x is equal to 2 by 3, the minimum value of this function is 8 by 3. Now what happens if you slightly come below? If you come below, you will see that for every y value, it corresponds to 2x values, correct? So if you come below, so one minimum value of y corresponds to 2x values. So for 2x values, you're going to get the same minimum value for y, correct? Because you have to come below this point. Above this point, what happens is one of the functions is going to be greater than the other functions. Below this point lies the curves wherein one function is less than the other function, correct? So if you look at the point which is to the right of this point of intersection, you will see x plus 2 is greater than negative 2x plus 4, and to the left you would see negative 2x plus 4 is greater than x plus 2. So that is why I am coming below this point of intersection, because below the point of intersection lies all the common points, all the minimum points. But then we've already seen that each minimum point corresponds to 2x values, which means this function is also not 1 function. In fact, you can see this function is not also an onto function, because the maximum value of this function is going to be equal to 8 by 3, and every other value is going to be negative. So this function has a range which is negative infinity to 8 by 3 and not the set of all real numbers. So this function is not an onto function also. So this function is clearly neither 1 nor onto. So this function is definitely not a bijective function. I like this question a lot, and probably you wouldn't have solved this question taking so much time. I have spent a little extra time to explain certain intricate details which is very important when it comes to relations and functions. In fact, the functions section of relations and functions. I hope you had a lot of fun solving this question and you have a better understanding of the domain and range of functions, and also the nature of 1 onto and bijective functions. We look at yet another question and explore some more concepts in that question. We've seen a wide variety of questions from functions. Yet another question that I am going to solve from functions is a typical question which appears in the main examination, wherein you'll have to find out the domain of a given function, right? So domain and range of functions is a very typical main question. Not many such questions appear in the advanced examination, but of course, when they appear in the advanced examination, they are going to be convoluted questions. The question that I'm going to solve is a pretty straightforward and simple question. We've been given the function f of x, which is defined as the sine of the log of x square minus 4x plus 4 divided by the greatest integer of x minus 1. Correct? So this is the function that we have in our hand. We have to find the domain. So what do you mean by domain? Domain are all the possible values of x that you can input into the function. Correct? That's the domain of the function. So let's try and find out what are the values that we cannot input to this function, or in other words, when we input those values, the function will become undefined, right? So the greatest integer of x minus 1 appears in the denominator, and we know that the denominator cannot be equal to 0. So greatest integer of x minus 1 cannot be equal to 0. When is greatest integer of x minus 1 equal to 0? When greatest integer of x equal to 1. When is the greatest integer of x equal to 1? When x is any value between 1 and 2 but not equal to 2. Equal to 1 but not equal to 2. So this function is not defined if x takes values between 1 and 2, 1 included, 2 not included. Okay? So if x cannot be equal to 1 to 2, 2 not included. Okay? That's one condition. There's yet another condition. Log x. Now log x is not defined if the argument is 0 or negative. So the argument of log x has to be a positive number. So x square minus 4x plus 4 has to be greater than or equal to, in fact greater than 0, because log x cannot take an argument of x equal to 0 also. So x square minus 4x plus 4 has to be greater than 0. X square minus 4x plus 4 is nothing but x minus 2 the whole square, and x minus 2 the whole square has to be greater than 0. Now x minus 2 the whole square is a positive number, and that is always greater than 0. Except for the case when x minus 2 equal to 0, because then x minus 2 the whole square will be equal to 0. So x cannot be equal to 2, because if x equal to 2, then x minus 2 the whole square will become equal to 0, and log of 0 is not defined. So x is equal to 2 is also an excluded value. So now, what are the values which you cannot input into this function? You cannot input any value between 1 and 2. Now both 1 and 2 included. So the domain of this function is a set of all real numbers minus the interval 1 to 2 with both 1 and 2 included as the excluded values. A little bit of wordplay there, included as the excluded values. But this is the domain of this function, R minus the interval 1 to 2, 1 and 2 both included. After having seen a domain question, it is only logical that we solve a range question also. So this is a range question. In this question, the objective is to find out what is the range of the function tan of under root of pi square by 4 minus x square. This is not a typical range question, because normally in a range question, you would write y is equal to f of x and then somehow express the function as x is equal to f of y. And then try and find out those values of y which cannot be input into the function x is equal to f of y, and those are the excluded values from the range. That's how you find out the range of a function. Here, if you do that approach, it's going to be very convoluted, because you will have y is equal to tan of this, which would give me a tan inverse of y, and then you have to square it. Going to make life a little more cumbersome. So let's do it in a different approach, which is going to be the easier approach here. So first, let's try and see what is the domain of this function. So the domain of this function, because there is an under root inside the argument, the under root term has to be always positive, which means pi square by 4 minus x square has to be always positive, which means that my x can lie between negative pi by 2 and positive pi by 2. That's all. X can lie between negative pi by 2 and positive pi by 2. What happens when I put the extreme values plus or minus pi by 2? When I put plus or minus pi by 2, my argument inside the under root becomes 0, which means my f of x is going to be tan 0. What happens when I put the value of 0 as x? If I put x is equal to 0, I get under root of pi square by 4, which is pi by 2. I get tan pi by 2. So these are going to be my extreme values of f of x. F of x is going to be tan 0 or tan pi by 2. So tan 0 is 0, tan pi by 2 is infinity. So this function is never going to be negative. Its argument of tan is always going to lie in the first quadrant, which means tan is going to lie between 0 and positive infinity. So this is a very, very quick way of solving this question and getting the answer that the range of the function is between 0 and infinity. A very simple, straightforward question. This is a typical IIT JEE main level question, not an advanced kind of question. So now I've solved a lot of questions from functions, but I've not solved any questions from relations, and that is because in the IIT JEE advanced examination, normally no questions come from relations. It's functions which is extensively tested in the advanced examination. But that doesn't mean that relations is a topic of less importance. In the main examination, inevitably one question comes from relations, and this question is going to test your understanding of equivalence relations mostly. Sometimes the question might be from binary operators. Mostly the question is from equivalence relations, which tests your understanding of a transitive, reflexive, and symmetric relation. So yes, relations and functions, an important chapter, and I hope I have solved some different variety of questions here, given you slight insight into how questions in the IIT JEE advanced or probably main examination is from mostly the chapter on functions. Do solve a lot of questions from functions and relations, and make sure that your preparation for this chapter is sound. And for any more assistance, you can always download the Byju's learning app and look at our videos there, and of course contact us in case you have any doubts. You have a lot of fun studying and preparing for the IIT JEE advanced and main examination, and I'll see you very soon with a few more interesting videos.
For more videos and live lectures on the JEE, click on the subscribe button now.